Hello, it's Scott Manley here, and it is boom time in Shenzhen. We are, well, what are we doing here? We are feeling the connection! No, we're not, that's some spam. Okay, the Poseidon, a decentralized autonomous corporation, has determined that thorium mining operations can be optimized by as much as 2.7% by creating a device with certain specifications. The specifications are included in this communique. I see, which probably means it's in the folder. Okay. A decentralized autonomous corporation is a company run without human involvement. It's a robot corporation! But the good news is these robots do provide pretty good specs, and the main thing to take away from this is that there's two main regions, right? One adds 30 and the other adds 50, and you just kind of merge them together, so that's what I used when I came up with the design. So with the specification in hand, let's get to work. So we have two inputs, an X and a Y input, and we basically need to send a power level out from this. And I think I can do this with two of these MC4000s because we have one to basically do the logic in the X axis, and the second one will do the logic in the Y axis, and basically the two of them will get summed together and sent to the power output. So connecting them up like this, we'll send the data from this across an X bus. I was connecting it via the power bus there, which was obviously in error. So the verification signal we have, if X and Y kind of move around and vary. So let's start with, shall I start with the X or the Y? I probably should start with the X because it's on the left, and I am a slave to my notion of progression that comes to me from Western languages. So we're going to test to see if the X signal lies within the 0 region, essentially. So if the thing is greater than 20 and if it is less than 60, right, then we will send the appropriate values out on the X bus across to its compatriot that will be working on the Y axis. So move 30 onto X1 and let your friend take care of it, and the negative version, so set that to negative, we will move 0 to X1 and we will have, yeah, I think that's right. Okay, so now we need to do the X test for the little hotspot section in the middle, and we're going to send the result of that along X0, right? So looking at the diagram, it has to be between 40 and 80. If it's between those values, it could potentially add 50 to my output. However, it would have to still be in the Y range. So yeah, we'll do that, and then if the both of those are true, we send a signal on the X0 bus. I guess I can just send 50 along. Maybe I can use that result. I mean, I guess it doesn't matter because the number isn't going to be relevant. It just needs to be low or high. Finally, of course, we need to sleep. Sleep. There's sleep for one, and this just fits in and no more. So I knew I could fit it into this amount of space. I was thinking I might need an MC6000, but no. Okay, so what do? We need to move the input into the accumulator because we're going to have to do arithmetic on this, and that's the only place we can do arithmetic. The next thing we want to do is check the value of X1, right? So we're going to test if X1 is equal to 0, and if that is true, then it means we're fine. We can just jump over to the end and send the data and be super happy fun time. So create a jump point here to send, and with the send we will move the accumulator out to P1, and then we will sleep. Now we need to fit in the logic to figure out if the Y-axis lies within that zone. So we've said the X values are in the correct range. Now we need to check the Y values. So we're gonna test if P0 is greater than 40, right? Or test if it's less than 80. If both of those are true, then we will send data. We will add 50 to the accumulator, and this thing should be totally working. If I can at least type 50 without messing it up like a dozen times. Okay, I think we're ready to simulate. Apparently we're not ready to simulate because I'm wrong. I've made some fundamental error somewhere, and had we deployed this in the mining of thorium, we would have probably caused a nuclear accident, and that would not be a particularly proud moment of my career. What's going on here? For some reason, we are going... Oh, you know what? Yes, I got my logic back to front. If those are both true, yes, there we go. Okay. Click, 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 click. Excellent. I'm feeling like some clicking here. Oh, wait, I missed one here. So what's happening here? Simple. Okay, so the X value is 20, and I trigger on 20, so I'm going to trigger on 19. We're not going to change the instruction. We're just going to bump that up by a point. Are there any others that I should change? I honestly don't know. I think maybe this one. I'm looking at the spec. This one should be 39. So let's run it again and look for any red ink. This is my second attempt at this. Things are going pretty well. Nothing has exploded yet, but that's why we test things. Of course, the theoretical advantage of thorium is that you can't really build a nuclear weapon out of it. Oh, and we've missed another one here. We still have a dirty weapon here. Okay, so sample input has to be 40, so that needs to be 39. 39. This is it. I can feel it. I can feel this is working. I know this thing will be going and mining thorium, and my little baby piece of hardware will make the world a safer place for nuclear reactors everywhere. Excellent! Okay, my power usage isn't that good. My production cost is rock bottom. Task verified! What a future we live in! That was cool! Yeah, that guy is super easily impressed. Okay, new supplier agreements. We have a digital I/O expander and the 4000X microcontroller. I thought we already had the 4000X. I will, of course, have to read the tech sheets to get really figure out what those are. But hey, hope you all sitting down right now because this is going to be big. How big, you ask? Well, you might just be talking to the guy who negotiated a deal to make all of the light-up color-changing vapes that Cool Dad is going to give away on this year's global tour. Dang, am I right? This is a huge deal for us. Literally millions of these are going to be given away. Looks rather straightforward. We get color values. We send it to LEDs. Excellent. A little tip, see the triangle at the beginning? That's when all those values are coming in. It's not like it's one per time unit. Okay. Shame that Cool Dad's actual music, if I can either call it like that, sounds like a 2000 era dubstep crossed with a parliamentary debate, if Parliament were ever populated entirely by screaming macaws. And of course, the girlfriend is a fan. Well, anyway, the way this works is I get a little data packet. You'll get 4 values in, and you need to set the 3 different LED values in this. Now, you might think this little multiplexer would be an excellent device for it. However, I looked at the spec sheet and it can only generate 100s and 0s. And if you look at the actual verification steps, then for this you actually need to produce half values. Hence why I'm going to use this MC4000X as a controller for 2 of the values, whereas this will control 1. So 2 of the LED values are going to be controlled from the subcontroller, and the main logic box will control 1 of the values. So I need the main one to be bigger because it's going to have a lot more logic on it. This simple one here will just sleep until we get data on X0, and then when it happens, it will move the first value into the P0, and the second value will get moved into P1, and so that should be the green and the blue, I would guess, but I don't honestly know. And then that's us, that's our loop. All we need to do is set that. Now the main loop, first of all, we're going to grab the X value and we'll stick it in the DAT feature, the DAT location, because of course it will be transient. If we read it more than once, it'll go away. If it's greater than minus 999, then we actually have actual data. Otherwise, we'll just skip over most of this. So, first thing we're going to do is we're going to move the X value, the first value, into the red location. The second value we will forward onto our second controller, so we'll send that on X2. Again, forward the next value onto X2, and now the final value is the pulse duration, and I'm thinking what I'll do is we'll stick that in the accumulator, and we'll do like a subtraction on that every cycle. So, we should test if the accumulator is greater than 0. So basically, if the accumulator goes to 0, we should turn off all the lights. So actually test if the accumulator is 0, and if that's true, send 0 values everywhere. Everyone, turn it all off! So move 0 to P1, move 0 to X2, and then move 0 again, another 0 to X2. So that will be my 3 color values set to 0. We'll run the subtract so that we will slowly decrement this, and I guess we should sleep. And that should be our awesome dubstep vape flashy lighty thingy. Let's run it, and I have made some foolish mistake already. So let me just step into this, hold on. We're kind of just moving the items from the input bus. We've moved one, that's red, but there's no red here. Why am I getting red when I don't want red? Have I got the wrong line? Oh no, no. Okay, so what I've done is I moved the stuff into the DAT register so I could check it, and I then therefore should have moved it on from there. So now we have the awesome cool dad flashy lighty vape thingy. I don't know what that is. Look at it! It's the visual representation of screaming parliamentary macaws. And did okay in production cost. I could improve on power usage, but well, you know, here's the thing, you may not get perfect use first time. Okay. Greetings. With every product we take, the factors we can control and factors we cannot control. We could not control the fact that Cool Dad was arrested and jailed for possessing amphetamines as he attempted to enter Japan, thus cancelling the world tour. However, we should have negotiated terms of the deal so that we wouldn't fail. Shenzhen days, things visitors say. Wait a second! I thought China was communist, so why is everyone shopping at the store? What is up with that? She has really interesting, use of caps there. Seriously, your use of caps is very impressive. Okay, I'm wrapping up a project to make a games console and could use some assistance. Before you get too excited, it's more fun than it actually is. The console is just a tiny super cheap box we're making for Sleep Cubes, the big Japanese capsule hotel chain to stick in every pod. The game's just some sort of free dross they'll find, I'm sure. At any rate, I need to make a controller, an interface, like a controller interface thingy. And well, let's figure out. Okay, so we have X and Y that will connect to a joystick. A and B are button inputs. Radio RX and radio TX. So, we have basically a logic table here, and that means we can actually use this. So this is a multiplexer. What it does is you can read in analog values and it will output digital values. And so I'm just going to set up this little MC4000 as a logic probe just so I can get my values, get my reference points. So we'll just move X3 into the accumulator and then we'll sleep, right? That'll be my cycle. And now I can step through the code, and actually see the values that go in there. So wait for it, one button gets pressed, I get 1 in the accumulator, and both buttons I get 11. So we're going to take those digital values and convert those into the output. Next. Okay. So take the MC6000, drop that in somewhere. This is going to have to read in the 2 analog inputs from the X and the Y, so that will be P0 and P1. I am going to have to skip it over things, but maybe, yeah, here, let's do that. And then the X2, so that will be my 2 transmitter connections. I can bring one connection round there, and bring another connection round here, and I still need the output from this, so I am going to have to use a bridge, which is free, so I don't know why I was trying to avoid using a bridge. Probably because I'm just a cheapskate. that doesn't even want to put in something that's totally free. Okay, so I need to, every cycle, right, when we get a signal from the transmitter which has a value of -1, we need to send our data out. So we're going to test if, now wait a second, receive, if x2 is equal to -1, then we do all our logic. Otherwise, we just sit in a loop and wait for something to happen. So maybe we should actually test if it's equal to -999 and then just jump over everything. Jump to the end. Go to the end of the program. Do not pass go. Do not collect $200. Just jump there and be all done. So sleep 1, and then that is our loop. So all the rest of the logic has to fit into this space. So this is the one that will construct our data packet. So first thing we need to do is send the x and the y values, and those are simple enough. So we move P1 into x3. I think, well, actually, let me just consider this. Is there any requirement that I modify these values or anything? I don't think so. Really, I'm just trying to think. Hold on. Brain fart. I forgot what I was doing because I'm getting old. No, wait. P0. P0 goes into X3. Okay, sorry. I got distracted by a thought about multiplexer. So the multiplexer, now we're going to have to read in the value from that and put it somewhere. So do we put it in the data thing or do we put it in the accumulator? Truth be told, I have enough instruction space that I shouldn't need to do either. So I can test if x1 is equal to 0. And if that's the case, we'll just move the value 0. So we have, I think we have 8 instructions here. We should be able to do them all. Test if x1 is equal to 1, in which case we will move the value of 1 to x3. There, so that will be, we're basically, so what's happening here is that multiplexer does a bit mask, but the bit mask is base 10, whereas the output mask is base 2. So we're having to test if that's 10, and if not, we will send 3. Okay, so if it's 10, we send 2, if it's 11, we send 3, and wait a second, I'm sending extra data here because I'm foolish. We're sending, okay, yeah, I mean the problem is that you can't just take the output from this multiplexer because it's base 10 and you need it in base 2, and I should have actually not skipped over the completion there. I should have actually explicitly tested for that, and that is looking a whole lot better. Oh wait, no, we're still getting extra data. We're still getting, that is because I have made another mistake here, so I should have switch that over. There, another fatal mistake. Although it'd be very hard to imagine how this could be fatal because this is basically a crappy video game system. Now I think that is a solution. I think I can do this in fewer lines. So what I'm going to do is we're going to move the x1 value, right? We're going to read the value from the multiplexer into the accumulator, right? Now, so think about this, the first bit we agree has a value of 1, but the second bit has a value of either 10 or 2. So all I need to do is subtract 8 from the 10 to get it to equal 2, and we will have a valid thing, and I've taken my 8 instructions and converted them to 3, which is not bad as far as I'm concerned. There we go. Look at all those fast control inputs. We can totally put like a mad pro gamer sticker on this, say 0 latency, when your gamepad absolutely needs to respond to your touch instantly. I think that's pretty good, but I'm going to actually point out, if you're doing this and getting stuck on a certain level because you can't match somebody else's cost or power usage, it could be because they're using parts that you have yet to unlock, or indeed other things. Like, if I hadn't really looked up the details in this multiplexer, I might have been tempted to just have a second controller here. Anyway, let's go back and see what they think of our awesome thing. Thanks, mate, I owe you one. You've helped me make thousands of dead tired salarymen marginally happier. Okay. So I was chatting with a mate at the pub and it comes to light that those Cheng Shang microcontrollers we use everywhere have a secret instruction that isn't in the documentation. So yeah, this secret instruction allows us to do the equivalent of 4 other instructions. So now I can potentially go back and rewrite some of my old code to make it more compact. Not necessarily faster because I think the power usage is the same. So with this and other revelations about the instruction set, I now feel that I have to go back and re-optimize my own stuff, but of course that will be in other episodes. Until then, I'm Scott Manley. Fly safe.